Here's example 16 of solving trig equations. So here we have secant squared of theta plus 2 times the tangent of theta equals 0, and we're going to solve this in the interval 0 to 2 pi. So this just means that 0 is less than or equal to theta, strictly less than 2 pi. Okay, so just like in the last couple of examples, the first thing we're going to do is use a trig identity. And the reason is here we have a secant squared and then here's a tangent. We would like to get everything in terms of just one trig function if we can. So what we want to do is think about, is there some trig identity that relates secants and tangents to each other? And yeah, there is. There's one that says, so it's one of the Pythagorean identities. It says secant squared of theta equals tangent squared of theta and then plus 1. Okay. So secant squared of theta is the tangent squared of theta plus 1. So we're going to use this identity to get rid of the secant squared theta and replace it with tangent squared of theta plus 1. Okay. So when we do that, we end up with tangent squared of theta plus 1, and then we still have the plus 2 tangent theta, and then equals 0. Okay. So now, here's the theta. Okay, now, so just like in the last few examples, we kind of have something going on here where we have a tangent and then a tangent squared. So we have a thing and then a thing being squared. So what kind of thing does that remind us of? Well, if we have a thing and then that thing squared, it's kind of like a quadratic equation, right? So we'll say let's A equal tangent of theta, okay, then A squared equals tangent of theta, that whole thing squared. Okay. But remember that a short way of saying that is just tangent squared of theta. So what's the point of doing that? Well, now if we go back to this equation here, so if we use this substitution here, here's A, and then here is A squared. Okay. So now the equation becomes A squared plus 1 plus 2A equals 0. Okay. Now, so the reason we did the substitution is because we wanted to take this big, ugly equation here and turn it into something that's more familiar, easier to work with, because this one right here is just a plain old regular quadratic equation. We know how to handle that. So first, let's write it in a more standard form. A squared plus 2A plus 1 equals 0. Okay. Now we can factor that, and that's just going to be A plus 1 times A plus 1 equals 0. Okay. So really, or A plus 1 quantity squared equals 0 is another way we could write that. But anyway, the only thing that we get from this is A equals negative 1. Okay. A equals negative 1, that's all we get from that. So now let's come up here. So A equals negative 1. Okay, but we're not done yet, right? Why not? Because we're solving for theta, we're not solving for A. Okay, so we have to back substitute now. If A is the tangent of theta, and A equals negative 1, then tangent of theta also equals negative 1. And from here, it's really just a matter of knowing the unit circle. So, because negative 1 is a special value associated with tangents on the unit circle. So here we're solving in this interval 0 to 2 pi. So we want to know what values of theta between 0 and 2 pi have tangent of theta equal to negative 1. And again, it's just a matter of knowing the unit circle, and those values of theta are theta equals 3 pi over 4 and 7 pi over 4. Okay. And again, that's really just a matter of knowing the unit circle, knowing the special values there. So if we were to draw those on the unit circle, x-axis, y-axis, big old unit circle, it's pretty bad. But anyway, we know that tangent is negative in quadrant 2 and quadrant 4. So 3 pi over 4 is this one here in quadrant 2, and then 7 pi over 4 is this one here in quadrant 4. Okay. So, and again, it's just a matter of knowing these special values on the unit circle. So that's it for example 16 of solving trig equations. And we have 3 pi over 4 and 7 pi over 4.